All right, so we're going to start this by doing a little review of Unit 2 with regression, particularly where it pertains to the computer output and the interpretations of that. So on the AP exam, we went over a lot of different ways to calculate linear regression, but the most common way is they give you a computer output and then you need to know how to read it. So you'd have just the part in black if you got this question on the AP test. Sometimes they give you more info, sometimes less, but this is generally what you would have. So right here it says predictor, and then under it says constant. And then under that, it's going to have a variable. Whatever variable is there, that's the x variable. The number next to the constant is the y-intercept. The number next to our x variable is the slope. So when you write your equation, you write y hat equals your y-intercept plus your slope times x. If you wrote y hat equals 0.8710x plus 107.58, that would be the same thing. Make sure you also define both your variables. So x is my age in years. I know that it says h here. And then y is the range of motion. In the original information they gave you on this, they told you it was range of motion. You would have more information than this. Then down here, it gives you s. We're not going to use that number. Gives you, it says r-sq, that means r squared. So my r squared is 30.6% or 0.306. To calculate r, you convert r squared to a decimal first. So you're going to have to convert to a decimal first. So I would move the decimal over twice. That's going to be 0.306 for r squared. I take the square root of that. So the square root of 0.306 so 0.5532 is r, but remember r can actually be negative or positive. But when you take the square root of r squared, you're always going to get a positive number. So to determine if it's positive or negative, you check the sign of the slope. So my slope was positive, so that means r is positive. But if the slope was negative, that would mean r is negative, so it would have a negative relationship. I'll come back to these numbers, but these are the numbers that would be used for the regression inference. The SE coefficient, T, and the P, which is for the p-value. So we'll come back to that in a different video. You won't actually be using it this year on the AP test. R squared adjusted is not a thing that we're ever going to use for this course, so just ignore that. So really, all you need are these three numbers and then the x variable. The next step is to write the next thing on here are the interpretations. So we've got our slope, that's going to be b in the equation. So it's always the number in front of x. For each increase of the x variable of 1 x unit, there's a predicted increase or decrease in the y variable of by units. So in this case, my slope was 0.8710. So for each increase in age of years by 1 year, there's a predicted increase of range of motion of 0.8710, I think it was degrees. Then y-intercept. When the age in years is equal to 0, the predicted range of motion is equal to 107.58 degrees. Now, there's nobody who's 0 years old who's having the surgery, so that's probably beyond our scope of data. The y-intercept would probably not be relevant in this case. My correlation coefficient, remember we said, was positive 0.5532. So there is remember, strong is anything between 0 and 0.5. Strong is anything between 0.8 and 1. Moderate is anything between 0.5 and 0.8. And then weak is anything between 0 and 0.5. Sorry. And then my coefficient of determination, 30.6% of the variation in range of motion can be explained by the approximate linear relationship between age and range of motion. And then we don't have a residual yet, but the actual y variable is however many degrees above if it's positive, below if it's negative, the predicted range of motion. So this is a regression study sheet. It's beautiful. I've posted it for you as well, so you can print this out if you have that ability. If not, hopefully I can give you a copy when we get back to school. I would definitely recommend doing colored ink if you can. Now I'm going to switch to regression inference notes. So we're just going to do the first side of these. This outline is also posted on Canvas if you want to print it, or you can just do it on a different sheet of paper. So I recommend that you pause this video right now and you attempt to do this side of the page on your own. We'll come back together and we'll do it together, but you should pause and attempt it on your own. Or attempt a couple parts, watch me do it, and then pause it again. What is the equation for the least square regression line? So remember that starts with y hat equals the constant, this is your y-intercept, right here, and then your slope right here. So y hat equals negative 87.12 plus 1.5433 x. And remember this variable is x. X is equal to the height. And it says here that the height is in feet. I like to put that in parentheses. It helps me when I write my description. And then y is the volume, which is in, no, not feet. It's in yards cubed. For my correlation coefficient, remember the correlation coefficient is R. So R is equal to, remember it can be positive or negative. In this case, the slope is positive, so R is positive. But slope can also be negative, so you need to watch out for that. Square root of 0.358. Remember, you have to convert to a decimal before you take the square root. So it's 0.5983. The coefficient of determination is R squared, which we know R squared was given to us. It's 0.358. It can be written as a percentage if you prefer. Both of these would be considered correct. The next part asks you to interpret the slope in context of the problem. So we can look at our regression study sheet to help us with that. For each increase of 1 foot in height of trees, the predicted, remember that word predicted is important. You can do predicted, or you can say on average, but you need something to indicate it's not always that exact amount, but rather a predicted or an average amount for the increase. 1.5433 yards cubed. That doesn't make sense. The predicted volume increases by 1.5433 yards cubed. That makes more sense. Remember, slope is change in y over change in x. That helps me remember which variable goes with which. So I'd have 1.5433 on top, and that would be my y variable. So that's yards cubed. And then I'd have just a 1 on bottom, and that would be my x variable, which is feet. So for each increase of 1 foot in height of trees, the predicted volume increases by 1.5433 yards cubed. Correlation coefficient. That was R, which was positive 0.5983. So there is a, so we need to determine if it's strong, moderate, or weak. So we look at this number. Remember, anything between 0.5 and 0.8 is considered moderate. Positive, because the slope was positive. Linear relationship. Between height and volume of trees. Interpret the coefficient of determination in context of the problem. So it's R squared, it's 35.8%. So that's what we start with, 35.8% of the variation in the y variable, which is volume of trees, can be explained by the approximate linear relationship between height and volume. Find the residual for a tree Find a residual for a tree with the height of 60. So remember, height is our x variable, and a volume of 7 yards cubed. So they're saying the actual height is 60 and the actual volume is 7. So since it's the actual volume, that's y. You should recall a residual equals y minus y hat. So to figure out y hat, I plug x into my equation from earlier. So negative 87.12 plus 1.5433 times x, which is 60. Type that in. So negative 87.12 plus 1.5433 times 60, 5.478. Yards cubed. So now for my residual, I do y. So the actual y is 7 minus y hat is 5.478. So 7 minus 5.478. 1.522 yards cubed. That's my actual answer for what the residual is. Next step is to interpret the residual in context of the problem. So we have a positive residual. So I would say the actual, remember this is referring to the difference in the y variables. So the actual volume of this tree is 1.522 yards cubed. And notice this is the actual. And this is the predicted. The actual is larger than the predicted. Hence the reason we got a positive number. So the actual volume of this tree is 1.522 yards cubed above the predicted volume. That could have been above or higher or greater than the predicted volume. Basically just saying that it's a difference, which one's higher. There you go. So you can rewatch this if you need to. You can ask questions. You can email your teacher. Remember, this should be in here. Strong is between 0.8 and 1. Moderate is between 0.5 and 0.8. And then weak is between 0 and 0.5. But these are guidelines. If you have a number, follow these guidelines. If you're just looking at the graph and you're not sure if it should be strong or moderate, call it moderately strong. If you're not sure if it'd be weak or moderate, call it moderately weak. Or if the number is right on the border. But if it's not on the border, go ahead and follow these guidelines. Okay, hopefully this helps. Email your teacher or come to office hours if you have any questions. Bye.